Friends, we measure moisture in oil. But moisture damages paper. That gap between what we measure and what actually fails the transformer is where many engineers get misled. This is exactly why the moisture Oommen chart exists. The Oommen chart does not give you another number. It gives you the missing link. How oil moisture, oil temperature, and paper moisture are connected at equilibrium. A transformer can show acceptable oil moisture and still have dangerously wet paper. If you don't understand the Oommen chart, you are only seeing half the picture. In today's Electroverse episode, we decode the moisture Oommen chart. What the Oommen chart really represents. When it can be used, and when it cannot. How to estimate paper moisture from oil samples. Why temperature changes everything. And how senior engineers use this chart to assess insulation risk. Stay till the end, because the Oommen chart turns oil data into insulation truth.
Today we reach the real problem area, because oil is not the insulation, paper is, and moisture inside paper decides transformer life, reliability, and failure risk. This is the fundamental truth that every power engineer must understand when dealing with transformer insulation health. When we talk about moisture in transformers, most engineers immediately think about oil moisture levels. They check the parts per million readings, compare them with standards, and feel satisfied. But this approach misses the critical point entirely. Oil only shows a reflection of what is happening in paper. The real danger lies hidden within the cellulose insulation, where 95 to 99% of the total moisture actually resides. This is why senior engineers never ask only how much moisture is in oil. They ask how much moisture is in paper. Because paper stores almost all the moisture in a transformer, and this moisture content directly determines the insulation's dielectric strength, aging rate, and ultimate failure risk. Understanding this distinction is crucial for proper transformer maintenance and life assessment. The challenge, however, is that you cannot directly measure moisture paper without opening the transformer, damaging insulation, and taking paper samples. This would be completely impractical and destructive for operational transformers. So how do we estimate this critical parameter? This is where the Oommen chart becomes invaluable. The Oommen chart is a widely used engineering correlation tool that provides an indirect method to estimate moisture percentage in cellulose insulation. This chart correlates three key parameters: moisture in oil, measured in parts per million, oil temperature, and relative saturation percentage. By plotting these values on the Oommen chart, engineers can estimate the moisture content in paper insulation with reasonable accuracy. This method is not just a field practice, but is formally referenced and accepted in international standards. Both IEC 6422 and IEEE C57.106 recognize the Oommen chart method as a valid approach for moisture assessment and transformer insulation. These standards provide the technical foundation for using this correlation in practical engineering applications. The Oommen chart works on the principle of equilibrium between moisture and oil and moisture in paper at different temperatures. As temperature changes, the distribution of moisture between oil and paper also changes. The chart captures this relationship and allows engineers to work backwards from oil measurements to estimate paper moisture content. This indirect approach has proven reliable over decades of field application. Understanding moisture levels and their implications is critical for transformer management. Industry standards define clear categories for insulation health based on moisture content. Dry or healthy insulation contains moisture below 2%. This represents the ideal condition for maximum insulation life and reliability. Between 2 and 3% lies the caution zone, where increased monitoring and preventive actions become necessary. Above 3 and 4%, insulation enters the wet or dangerous category. At these levels, the risk of dielectric failure rises sharply. When moisture reaches 5%, insulation life reduces dramatically. The relationship between moisture and insulation degradation is not linear but exponential. Just 1% increase in paper moisture can reduce insulation life by more than 50%.
These moisture thresholds are not arbitrary numbers, but are based on extensive research and field experience. They represent the points where different failure mechanisms become active and where the rate of insulation aging accelerates significantly. Understanding these boundaries helps engineers make informed decisions about transformer operation and maintenance. High cellulose moisture creates multiple dangerous conditions within the transformer. First, it reduces dielectric strength, making the insulation more vulnerable to electrical stress. Second, it accelerates the aging process through hydrolysis, where water molecules break down the cellulose polymer chains. Third, it increases partial discharge activity, which further degrades the insulation system. Perhaps most dangerously, high moisture content leads to bubble formation at elevated temperatures. When transformer oil reaches high temperatures during overload conditions, dissolved moisture can come out of solution and form gas bubbles. These bubbles have much lower dielectric strength than oil and can cause sudden electrical breakdown. This is very dangerous because it indicates wet insulation, high bubble formation risk, and the possibility of sudden failure during overload. This is where many transformers fail without DGA dissolved gas analysis warning. Traditional DGA monitoring focuses on gases produced by thermal and electrical faults. But moisture-related failures can occur suddenly without producing the typical fault gases that DGA systems detect. This makes moisture monitoring through the Oommen chart even more critical for preventing unexpected failures. Many engineers trust oil parts per million readings and ignore paper moisture. That is a dangerous mistake. Transformers do not fail because oil is wet. They fail because paper is wet. Oil moisture shows symptoms, relative saturation shows stress, but cellulose moisture decides life. This hierarchy of importance must guide all moisture-related decisions in transformer maintenance. When the Oommen chart indicates high cellulose moisture, specific engineering actions become necessary. First, identify and control moisture sources. This includes checking for leaks, improving sealing systems, and ensuring proper breather maintenance. Second, implement oil dehydration under vacuum conditions. This process can help remove moisture from both oil and paper, though paper drying is a slow process that requires patience. Third, avoid high loading conditions that could trigger bubble formation. High moisture insulation cannot handle thermal stress as effectively as dry insulation. Fourth, establish continuous trend monitoring to track moisture changes over time. This helps identify whether moisture levels are stable, increasing, or responding to treatment efforts. These actions align with recommendations in IEC 6422 and IEEE 57106 standards. The key principle is that paper drying is a process, not a quick fix. It requires sustained effort and careful monitoring to achieve meaningful moisture reduction in cellulose insulation. The Oommen chart turns oil data into life-critical insight. By correlating easily measured oil parameters with difficult-to-measure paper moisture, it provides engineers with a practical tool for assessing transformer health. This correlation has saved countless transformers from premature failure by enabling proactive moisture management.
Understanding the technical aspects of moisture in cellulose through the Oommen chart represents a fundamental shift in transformer maintenance philosophy. Instead of focusing solely on oil quality, engineers must consider the complete insulation system. The chart provides the bridge between accessible oil measurements and critical paper condition assessment. In conclusion, moisture in cellulose paper, not oil, determines transformer life and reliability. The Oommen chart provides the engineering tool to estimate this critical parameter indirectly. By understanding moisture thresholds, recognizing the dangers of wet insulation, and implementing appropriate corrective actions, engineers can significantly improve transformer reliability and extend operational life. Remember, oil moisture shows symptoms. Relative saturation shows stress. But cellulose moisture decides life. This fundamental principle should guide every moisture-related decision in transformer engineering and maintenance.
So friends, this is the real meaning of the moisture Oommen chart. The chart does not measure moisture. The chart interprets moisture. It tells you how wet the paper insulation really is, whether aging is slow or accelerating, and how temperature shifts moisture between oil and paper. Remember these rules forever. Oil moisture alone is incomplete. Temperature controls moisture distribution. Paper moisture decides insulation life. The Oommen chart is valid only when the transformer is thermally stable, operating normally, and not under sudden load change. Used correctly, it helps you decide. Drying urgency, load limits, and insulation risk. If this explanation helped you think like a senior transformer engineer, then support Electroverse. Like this video. Comment below. Have you ever used the Oommen Chart in your analysis? Subscribe, because next we connect moisture, BDV, and bubble formation risk. You've been watching Electroverse, where every spark tells a story. Stay charged, stay safe, and happy.